Hello students, and welcome back to Chemistry A. I'm Ms. Slate, and today we're going to be talking about dimensional analysis. Dimensional analysis is a methodology for converting between different units, and it's something that's going to become very, very important, especially when you guys move on to Chemistry B. So this is a skill that we really need to make sure that we practice and we know well. And dimensional analysis all starts with a conversion factor. The conversion factor is simply a ratio that relates two different units. For example, 1 hour equals 60 minutes. That's a conversion factor. 4 quarts in a gallon, also a conversion factor. A ratio that just relates two different things. So let's give an example of how we would use this. With how many minutes are in 2.6 hours? Well, the first thing I need to figure out is what is the conversion factor between minutes and hours. Hopefully this is an easy one where we remember that 1 hour is equivalent to 60 minutes. Now, when we go to do the dimensional analysis, we'll want to set this conversion factor up as a ratio. But the first thing that we're going to do is we're going to take our given number, our 2.6 hours, and we're going to put that over 1 because we're going to be multiplying by a ratio. Now, we've got two options for how to turn this into a ratio. We could write it as 1 hour over 60 minutes, or we could write it as 60 minutes over 1 hour. Now, we want to pick the one that will allow us to cancel our units of hours and end with units of minutes. And that's going to be the second one. Another way to remember this is that it's always going to be whatever units that you want on the top. In this case, we want minutes. And the units that you already have or that you start with, in this case, hours, are going to go on the bottom, which means our ratio is 60 minutes to 1 hour, which gives us an answer of 156 minutes. And so it's just that simple to do dimensional analysis. Obviously, you don't necessarily need to do this kind of a process when going from hours to minutes. It comes more into play when we do more advanced metric conversions or other types of calculations that, again, you'll be doing in Chemistry B. So it's still an important thing to learn, even if we're starting with some basic examples. Let's look at another basic example. How many gallons are in 22 quarts? Again, the first thing we want to identify is our conversion factor. In this case, 1 gallon is equal to 4 quarts. Then we are going to take our starting amount, 22 quarts, and put it over 1. I need to multiply it by the conversion factor ratio that will allow me to cancel out quarts and end up with gallons. Well, quarts is the unit that I have, so it should go on the bottom. Gallons is the unit that I want, so it should go on the top. So my ratio should be 1 over 4, thus allowing me to cancel quarts and end with units of gallons. And we get an answer of 5.5 gallons. Now, some of you might be thinking, well, what about significant figures? Which is great. We should always think about significant figures. If we based it off the conversion factor, we'd only have one sig fig. However, we shouldn't be basing our significant figures off of the conversion factors. As a general rule, we just assume that conversion factors have an infinite number of sig figs. So your number of sig figs in your answer is always going to be based off of whatever the original amount is. In this case, 22 quarts has 2 sig figs. Our answer has 2 sig figs. So we've rounded correctly here. Let's apply this to the metric system. Remember, our base units for length, mass, and volume in the metric system are the meter, the gram, and the liter. And then we just apply different prefixes to those to represent different amounts of base 10. So here's kind of a big metric conversion table. Notice that in the center is what we call the base units. So this is meters, grams, or liters. And they're essentially just like a 1, right? And then it tells us that how much a kilometer is, or how much kilo, mega, and giga is. These are all bigger than your base unit. And then they also show us ones that are smaller than our base unit: deci, centi, milli, micro, nano, and pico. Keep in mind that micro, the symbol for micro, is the Greek letter nu, or mu. What the prefixes actually represent, you will be given a table of all these, what these metric prefixes represent, and you'll be allowed to use that table on tests and quizzes. So I'm not going to make you memorize that, pico is, 10 to the 12th, okay? So you will be given that information. Oh, another couple volume relationships we should be aware of is that 1 cubic centimeter is equivalent to 1 milliliter. 1 cubic decimeter is equivalent to 1 liter. So in this example, it says how many centimeters are in 0.26 meters? Well, I'm going to start with my given amount, 0.26 meters, put it over 1. We need to determine the conversion factor. 1 meter is equal to 100 centimeters. This is a pretty small conversion, so it's not necessary to put it in scientific notation. We have units of meters, so we're going to put those on the bottom so they cancel. And we want units of centimeters. In 1 meter, there is 100 centimeters. Units of meters cancel. And we end up with 26 meters. Again, we started with 2 sig figs, we ended with 2 sig figs, so that is our correct answer. Let's look at another one. This one is how many liters are in 106 milliliters? Well, in 1 liter, there is 10 to the 3rd milliliters, or you could just write it as 1,000 milliliters. Again, 1,000 isn't quite big enough to require us to use scientific notation. You could if you wanted to, though. And then I'm going to start out with my original amount, my 106 milliliters. Put it over 1. In this case, I want units of liters, so that should go on the top. I have milliliters, it should go on the bottom. Again, this is going to allow milliliters to cancel, so we know that's set up right. And I know in 1 liter, there's 10 to the 3rd milliliters. So this is going to come out to 0.106 liters. Let's look at a more complex situation. So in this case, they're saying how many kilograms are in 550 milligrams. Well, here's the thing to remember with our metric conversion chart. There's no direct conversion factor given to us between kilograms and milligrams. What we do know, on the other hand, is that 1 kilogram is equal to 10 to the 3rd meters, or not meters, grams rather. And we also know that 1 gram is equal to 10 to the 3rd milligrams. So because we don't have one conversion factor between kilograms and milligrams, we only have kilograms to grams and grams to milligrams, this conversion is going to require 2 steps, okay? Still a fairly simple process to work through. I'm still going to start with my 5,500 milligrams. And I'm going to put it over 1, just like usual. Now, the first thing I need to do is I need to convert from my first unit to our base unit. So I first need to use this conversion factor, milligrams to grams. In this case, I have milligrams, so it should go on the bottom. I want to get to the base unit, grams. Milligrams are canceling, so this means my ratio should be 1 over 10 to the third. Now, grams is not what I want at the very end, though. At the very end, I want kilograms. So next, I need to multiply by my conversion factor for kilograms to grams. Where again, I want kilograms at the end, so that goes on top. Grams goes on the bottom so that I can, again, cancel it out. This means my conversion factor should be 1 kilogram to 10 to the third grams. Then I just need to do the math. And this answer should come out to 5.5 times 10 to the negative third kilograms. This is the basics of dimensional analysis. Again, like I said before, it might seem like we're doing something overly complicated for what could be a simpler process, but this skill is going to be very important through the later parts of chemistry, particularly for a lot of the topics that you're going to cover in Chem B. So we want to make sure that we learn it and we get good at it now. If you feel like you've got a good handle on this, you can stop the video now. Otherwise, we're going to do one more of these multi-step example problems together. So in this problem, it states how many centimeters are in 0.27 kilometers. Again, there's no direct conversion factor from centimeters to kilometers. I do know that in 1 meter, there are 100 centimeters. I also know that in 1 kilometer, there are 1,000 meters, or 10 to the third. Again, we're going to start off by writing the original value that we're given, our 0.27 kilometers, and I'm going to put it over 1. Again, the first thing you want to do is you want to go from whatever unit you're starting with to the base unit. In this case, the base unit we're working with is meters. So I want to use my conversion factor between kilometers and meters. So I want meters, it's going to go on the top. I have kilometers, it'll go on the bottom. So that's 1,000 over 1. My units of kilometers are canceling, and I have units of meters. Again, what I want at the very end, though, is centimeters. So now I need to go from my base unit of meters to centimeters, the final unit that I want. I want centimeters at the end, so it goes on the top. Meters goes on the bottom so that it will cancel. My conversion factor is 100 over 1. And then I just do the math. And we get an answer of 27,000 centimeters, or in scientific notation, 2.7 times 10 to the 4th centimeters. And that's the basics of scientific notation. If you still find this a little bit confusing, that's okay. We're going to practice it a lot in class. And so I'll see you in class for lots more dimensional analysis practice.